वेलकम स्टूडेंट्स, आपका YouTube चैनल शंकर कोचिंग में स्वागत है। मैं प्रोफेसर प्रेम शंकर आज 12th क्लास के स्टूडेंट को NCERT बुक से 3rd चैप्टर मैट्रिसेस पढ़ाऊंगा। आप इस वीडियो को लास्ट तक देखें। अगर कोई डाउट हो तो कमेंट बॉक्स में लिखें। अगर मेरा ये वीडियो आपको पसंद आता है तो प्लीज़ इसको लाइक कीजिए, सब्सक्राइब कीजिए और अपने दोस्तों के साथ शेयर कीजिए। तो चलिए वीडियो स्टार्ट द वीडियो मैट्रिसेस। We will study one by one. Introduction, then types, then operation and properties, then elementary operation, then special properties. In the types, you will see the different types of matrices. Operation, we will discuss addition and multiplication. Properties to discuss, that is properties like commutative, associative, and other properties. Elementary operation in a matrices, how can you change the values of row and column. A special property, there are special properties also, like transpose is there, then adjoint is there, inverse is there. Actually, what is this matrix? Matrix is what? Matrix is the rectangular arrangement of elements or function. Rectangular arrangement means it has some row and then it has some column, row and column. So generally we represent the matrix by A, I, J, and here it is M cross N. The A, I, J is called the element of the matrix, while M and N, M is called the row and N is called the column. Suppose I want to expand this notation. So if I expand this notation and I represent the matrix with the capital letters, let's suppose one matrix is B and I want to represent this matrix by seeing this Aij. So I can arrange this matrix into a rectangular form, that is your A11, A12 and so on, A1n. Similarly, here it will be A21, A22 and so on, A2n. And similarly, we have the last one here, it will be the ANN, and here it is your AM1 and AM2 and so on, ANN, and here it will be M cross N. This will be your M, this is M. So this is how the matrix is represented. Now we see the types of matrix. In the types of matrix, we have the column matrix, row matrix, square matrix, diagonal matrix, scalar matrix, identity matrix, zero matrix, equal matrix, asymmetric and skew symmetric matrix. So we will start this types of matrix by its simple notation. The simple notation of this matrix is your this Aij, and here it is your M cross N. Again I am repeating, this Aij is the element of the matrix. It may be in a number or function. M cross N, in M cross N, your M is your row and N is the column. So seeing this different properties for different types, we will change these all one by one. So we will get it what? We will get the different types of matrix. For example, suppose column is there. In the column, what will be happen? If this n is equal to 1, if n is equal to 1, then it is what? It is your column matrix. N is equal to 1, then it is a column matrix. So I can say that in this case, what is happening? This Aij, and here it is your M cross 1. Means your this row, this column is 1. One column is there. while m rows are there. Similarly, this for the row matrix, if I represent the row matrix, this will be represented as Aij. It is Aij, and here it is your 1 cross n, 1 cross n. So in this case, this is your column matrix. Sorry, row matrix, because row is only 1. Now, next one is your square matrix. In the square matrix, what is happening? This Aij is there, but here this value of m is equal to n. Means your row is equal to column. Row is equal to column. Then it is a square matrix. Now the next diagonal scalar identity and 0. This matrix is defined in this case. What is happening? Always remember, diagonal scalar identity or 0 matrix. In this matrix, your this again it will be defined as Aij, and here it is m cross n. Okay. In all these matrices, you will find that if I is equal to j, if I is equal to j, then it has some values. But if I is not equal to j, then the value of Aij is equal to 0. But I is equal to j, it means what? It means it has some values. So for defining all this, I can say that in this matrix, I'm defining all these 4 with one example. Let's suppose this is your matrix A. A matrix is there, and when I is equal to j, then only it is defined. Otherwise, it is 0. So that means what? That means this is your A11, A22, A33, and so on. It is your A and N. And on the rest of the position, the values are 0. The values are 0. The rest position, the values are 0. Like this. So in the rest position, the values are 0. Okay. Obviously, this is your here it is what? Here it is your m cross n, m cross n here. So on this diagonal, the values are there. So then, if the value on the diagonals are there, so this is diagonal matrix. Okay. What is the scalar matrix? Scalar matrix means what? If the values on the diagonals are equal, then it is your scalar matrix. Identity matrix, the value on the diagonals are 1, then it is called the identity matrix. And 0 means what? The value at the diagonal, all are 0, then it is diagonal matrix. Again I am repeating, in the diagonal, scalar identity and 0. When I is equal to j, it has some value. But when I is not equal to j, that means the value at ij is equal to 0. So I can define in this way. So one thing important, that is your identity matrix. Identity matrix, this identity matrix is denoted by I, and its value is how much? Is, let's suppose I am taking the 3 cross 3 order 3. So the value will be like this: 1, this is 0, this is 0. So then 0, 1, 0, 0, 0, 1. So this is your identity matrix. Let's suppose I want to define 0 matrix. So that 0 matrix, let's suppose I am representing at A. So your this 0 matrix will be all 0, 0, 0. This is 0, 0, 0, 0, 0, 0. So this is what? This is a 0 matrix. Now next we come the equal matrix. In the equal matrix, let's suppose two matrices are there, A, I, J, and suppose it is your M cross N, and this is equal to your Bij. This is also M cross N. Okay. So in this case, the equal matrix is what? Equal matrix is that whatever the value of Aij, that must be equal to Bij. Aij, that must be equal to Bij. So this is for equal matrix. Now come to the this symmetric matrix. So symmetric and skew symmetric matrix. If you any matrix is given and you just find the transpose of that one. Okay, transpose of that one, and you find that the values are equal, then that is your skew symmetric matrix. So for skew symmetric and skew symmetric, this is your symmetric and skew symmetric matrix. Skew symmetric matrix. I am giving you one example for this. Skew symmetric. Let us suppose it is denoted by it is denoted by, let's suppose, A. A is the matrix, and in this A matrix, I am giving one example. So it is a root 3, then 2, then 3, then 2, minus 1.5, minus 1, then your 3, minus 1, and 1. This is symmetric and skew symmetric. Why? Because if you change the row into column into row, so you will get the same thing. Suppose I'm changing the row into column and column into row, I will get the same matrix. So it is a symmetric matrix. So these are all the types of matrix. Now we will see the matrices. In the matrices, we will see the operation and properties. There are mainly two mainly applications are there. One is addition. One is your addition. And the second one is your multiplication. So first of all, I will take what? I will take the addition. In the case of addition, one thing always remember that both matrices will be of the same order. That is the necessary condition. And suppose in the case of addition, let's suppose I am discussing about the addition. Let's suppose A is given one matrix. I represent it Aij. Aij and M cross N. That is your first matrix. And I want to add the another matrix B, and that is equal to your Bij. That is also must be your M cross N matrix. The order must be same. So if you add it, you get what? You will get the A plus B. And this A plus B is equal to how much? This is your Aij plus this Bij. This is also of the same order, M cross N. Now in the addition, we will see some properties we will see. We have the properties, commutative properties. So suppose in the commutative properties, first property is your this is an addition. The first one is your commutative properties. Commutative properties. Commutative properties in this addition operation, it is true for commutative properties. Means what? Means your this A plus B is equal to your B plus A. A plus B is equal to your B plus A. And next one is your commutative properties. The next one is your, let's suppose, associative properties. Associative properties. Associative properties. So for the associative properties, it is your A plus B plus C. This is equal to your A plus B plus D plus C. This is your for associative properties. Now, there is one additive identity. Additive identity is your, that is defined your additive identity. It will define as, suppose, A plus 0. This is 0 matrix, and then 0 plus A is equal to A. So this 0 matrix is called the additive matrix. It is called the additive matrix. And let's suppose inverse of A. Let's suppose I want to find what is the inverse of A matrix. Inverse of A means what? Means if you take A, this is plus minus A, this is equal to minus A plus A. Minus A plus A, and this is your 0 matrix. This is your 0 matrix. Then this A is called what? A is called the inverse of matrix. Let us see the another one, the multiplication. See, the two matrices are given, and I want to find its what will the multiplication of those matrices. Let's suppose I am finding A is equal to, let's suppose it is A I J, and your next is order is M cross N. Next is your, suppose, B, and this B is equal to your B J K, B J and K. Order is N into B. So then your this A into B, that will be equal to suppose A into B. So that is suppose equal to C. So what will the value of the C? The C will be your, this is equal to your C I K, and this is your C I, and this is K, C I K, and it will be order of your M cross E. So this is the way in which you will define how to find this A and B. A into B, that is equal to your matrix C, that is equal to your C I K M cross E. Okay. Now, as I had seen in the case of the addition, the different properties. So here also I will see the different properties in the case of this multiplication. See, of the first one, that is the commutative properties. This commutative properties is not true. The commutative properties is not true for the case of this. Commutative property is not true for this multiplication. Means what? That is your A into B is not equal to, it is not equal to B into A. So associative property and commutative property is not true. Okay. Then this is the which property? This is the commutative properties. Commutative properties. It is not true for multiplication. This is not true for multiplication. Commutative property. Now come to the associative property. In the associative properties, it is true. That is A, B and C. So A, B, C, this is equal to your A, B and C. This is B and C. So this is associative property, that is true. So this is your associative properties. Associative properties. This is true. True for the case of multiplication of two matrices. Now the next one is your distributive properties. Distributive properties means suppose this A plus B is given, and suppose I am multiplying this by let's suppose C. So this is equal to your A, C plus B and C. So this is what? This is the distributive properties. Distributive. This is the distributive properties. And we had seen this additive identity, that is your zero matrix. Similarly, your this additive multiplicative identity. Multiplicative identity means that if A into I is equal to I into A is equal to how much? A. Then this I is equal to identity property. Identity properties. This will be an identity property. So in this way, these are the operation of addition, multiplication, and these are all of the properties. Now we will see elementary operation. In the operation, the operation is your. You can change the ith row to this jth row. Ith row you can change into jth row, and similarly you can change ith column into this jth column. You can change in this way. Let's suppose I have given any matrix. Let's suppose this is your 4, 5. This is 6 here. 3 minus 1, 2, 3, 4 and 6. Suppose this is given. I can change these row or I can change these column. And similarly, we have one more operation, that is you can change the ith row and you can multiply it by this k times ri. K times ri, you can do it in this way. Or for the column case, it will be your ci, you can change it into k times cj. Ci. K times ci. And the third one is this is first one. Third one is you can change ri. This you can change into this ri plus k times rj. K times rj. Or in the column case, this will be equal to ci. You can change into ci plus k times cj. So this is all about the elementary operation. We'll see the special properties of matrices, and then in this cases are transpose and their adjoint is there, your inverse is there. So let us suppose I'm taking the transverse. I'm taking the first one, that is your transpose, not transverse, transpose. So how to define the transpose? Let's suppose I have one matrix A. A matrix is given and that is denoted by Aij. That is your Aij. And this matrix is of the order m cross n. M into n. Now I want to find its transpose. So its transpose is written by your this is this is your dash, we call this A transpose, and this is equal to your A, this is nothing but J, I, and this M cross N is there, so obviously it will be your N cross N. So it will be your N cross M. So that is the transpose. What now we will see some properties also. In the case, some properties we will see. So the first property is that if you mix transpose to transpose, then you get the same matrix A. First thing. Second is if you multiply this by this constant. So K, suppose K into A transpose I want to find. So that is nothing but that is equal to K into A transpose. Similarly, if I take this, I have A plus B, two matrix, and I want to transpose of this one. So this is equal to simply A transpose plus B transpose. And similarly, the product of this product of two matrices given. So A and B transpose is given. So this is equal to nothing but this equal to, this is your firstly this is B transpose into A transpose, B transpose into A transpose. Okay, simple means if you change row into column, column into row, so in that case you will get the transpose. If you change that one, so this is the definition of this transpose, and then we have this. These are the properties of transpose. Now come to the next one, that is your adjoint. Adjoint is also very important. Adjoint. So in the case of adjoint, suppose I am taking the adjoint. So how to define this adjoint? So again, in the case of this adjoint, how to define? Suppose I have given one this matrix is given A, that is I represented by A, I represented by Aij, as usual. This is of the order 2 m cross n. M is m cross n order is there. So how to define the adjoint? So this is nothing but this is the transpose. It is what? It is the transpose of the matrix. That's adjoint. Adjoint. This is equal to what? This is equal to your transpose of the matrix Aij. Aij. It transpose. It will be your order. It should be your not n cross n. It should be the same order will be there. So n cross n will be there. So adjoint of this A. Adjoint of this A is equal to, adjoint of this A is equal to transpose of this Aij, and order will be n cross n. Okay. Where in this case, what is Aij? This Aij is equal to how much? Cofactor. Cofactor. It is equal to your cofactor of what? Aij. Cofactor of Aij. Aij is equal to how much? Cofactor of Aij. Okay. So this is your adjoint. See the properties of this adjoint A. The properties of adjoint A is, suppose adjoint A is given, adjoint A, and thus into A is there. So it is also equal to your A into this adjoint of A, and this is equal to your determinant into I. So this is the properties of adjoint. Now come to the last one, that is your inverse. Inverse. So two function are called to the inverse if A into B is equal to B into I, and that is equal to your I, identity matrix. So in that case, it will say that you can say that B is equal to A inverse, or A is equal to B inverse. This will be for the case of inverse. And how to find the inverse? So suppose A inverse you have to find. So A of inverse, that is equal to your 1 by A as a determinant, and then this is equal to your adjoint of A. Thanks for watching. If you have any doubt, to write in the comment box. If you like the content of the video, then please like it, subscribe it, and share with your friend. Thank you.